The characteristics of mechanical failures in industrial robots mainly include diversity, concealment, correlation, regularity, and complexity. To ensure the normal operation and performance of the robot, it is necessary to have an in-depth understanding of its mechanical structure and take effective maintenance and troubleshooting measures. Hello, everyone. Mechanical wear and tear failures in industrial robots, caused by factors such as prolonged operation, overload, and lack of proper maintenance, will lead to a decline in the robot's motion performance, reduced accuracy, or inability to work normally. In this lesson, we will primarily analyze mechanical failures in industrial robots. What are the mechanical failures in industrial robots? Let's explore this together. The mechanical failures in industrial robots mainly include gearbox failures, joint failures, load failures, motor failures, sensor failures, etc. These failures can cause a decline in the robot's motion performance, reduced accuracy, or inability to work normally. Gearbox failures. Now let's analyze the first type, gearbox failures. First, let's understand what a gearbox in an industrial robot is. The gearbox of an industrial robot is a key component of the transmission system, responsible for rotating and transferring power, playing a crucial role in the robot's movement. Common gearbox failures include gear wear, tooth breakage, and cracks in the housing, which can lead to decreased transmission efficiency, reduced accuracy, or the inability of the robot to work properly. Possible causes of these failures include gear wear, bearing damage, insufficient lubrication or contamination, and wear of internal components within the gearbox. Common symptoms of gearbox failures in industrial robots include vibration, abnormal noise, excessive temperature, unusual smell or smoke, and leakage of lubricant. Through regular maintenance and inspection, adjusting the fit between gears, replacing damaged bearings and lubricants, etc., the lifespan of the gearbox can be extended, downtime reduced, and production efficiency ensured. Joint failures. Next, let's analyze joint failures. Similarly, let's first learn what the joints of an industrial robot are. The joints of an industrial robot are a core component of its motion system, bearing the crucial responsibility for movement and positioning, typically employing rotary or pitch joint structures. Such failures may stem from bearing damage, gear wear, mechanical structure loosening, or control system issues, leading to inaccurate or unstable movements of the robot, or a complete stoppage. Joint failures can manifest as increased positional errors, vibration or shaking, abnormal noises, excessive heating, unsmooth movements, and motor overheating. Diagnosing joint issues involves examining key components such as sensors, encoders, motors, and mechanical structures. For bearing damage, it may be necessary to replace the affected bearings and check the condition of adjacent parts. If the mechanical structure is loose, it requires retightening bolts or adjusting mechanical connectors. Control system problems might necessitate updating or repairing related programs and parameters. Load failures. Next, let's learn about load failures together. Load failures in industrial robots refer to malfunctions caused by excessive or insufficient loads during operation. Such failures usually lead to deviations in the robot's motion trajectory, vibrations, and overload protection issues, affecting the efficiency and precision of the robot. The causes of load failures may include tool wear, uneven workpiece quality, environmental interference, etc. Common symptoms of load failures are decreased carrying capacity, positional deviations, unstable movements, or excessive vibration alarms under heavy loads. To address load failures, it is necessary to regularly check and adjust the robot's load status to ensure it operates within normal ranges. Additionally, enhancing the maintenance and care of the robot, Maintaining the precision and consistency of tools and workpieces, and optimizing the robot's control algorithms and parameters are important measures for preventing and resolving load failures. Motor failures. Next, let's continue to analyze mechanical failures in industrial robots. Motor failures. First, let's understand what the motor of an industrial robot is. The motor of an industrial robot is a core component of its power system, using servo motors as the driving device, responsible for driving the movement of joints and actuators. Motor failures can lead to performance degradation and reduce production efficiency in robots. Common motor failure symptoms include unsmooth movements, loss of control, abnormal noises, excessive heating, and current fluctuations. These issues may stem from short circuits in the motor windings, bearing damage, cable connection problems, unstable power supply, or control system errors. Through regular maintenance and monitoring, motor failures can be detected and addressed in advance, improving the reliability and production efficiency of the robot. Sensor failures. Lastly, let's analyze sensor failures together. First, let's learn what sensors in an industrial robot are. Sensors in industrial robots play a crucial role in sensing and acquiring environmental information, feeding this data back to the control system to achieve precise movements and operations. Sensor failures can negatively impact the robot's perception and decision-making. Common symptoms of sensor failures include incorrect environmental perception, malfunctioning distance measurement or positioning capabilities, and issues that prevent the robot from correctly responding to external changes. Such failures may arise from damaged sensor components, connection issues, environmental interference, or control system errors. Regular maintenance and monitoring are key to preventing sensor failures, including testing sensors, recalibrating, or replacing damaged parts. In light of the above cases of mechanical failures in industrial robots, we need to take corresponding measures for prevention and repair. For example, strengthen routine maintenance and care, regularly inspect and replace vulnerable parts, adjust and optimize the robot's mechanical structure, etc. Moreover, using high-reliability components and materials, improving manufacturing process levels, and enhancing quality control are also important measures to prevent mechanical structural failures. This concludes today's lesson. I hope you will review and consolidate your learning after class. Complete the following exercises and prepare for the next lesson. Thank you, everyone.